This is lab program number 22. In this particular program, I'm going to find the sum of all rows and sum of all columns in a matrix. So let me say if I enter number 1, 2, 3, 4, 5, 6, 7, 8, 9, I should get the row sum and column sum. We shall do the program and then verify. The explanation of this program has been done in detail in the theory session in a video prior to this. This is just the demo video. So please take a look at that explanation and then come to this particular program. I have defined a matrix A of 5. That means 5 rows and 5 columns. Variable R will tell me how many rows the user is going to enter. C is going to tell me how many columns. I is used to travel through the rows. J is used to travel through the columns. R sum and C sum are two variables used to store the sum of each row and sum of each column as we proceed to do the calculation. First is I am asking the user to enter the order of the matrix. So he enters the number of row and number of columns. So I am asking him to enter the rows and column data using this particular loop. I is less than the number of rows, J is less than the number of columns. Once this data entry is done, let me first proceed to find the sum of rows. So what I am going to do here is I am going to say for I is equal to 0, I is less than the number of rows and I plus plus. This is my outer loop. Then what I have an inner loop for, okay, before I do the inner loop, let me put a bracket. The reason being I am going to use a variable called row sum. I am going to make it 0 because for each row it should start with the initial value of 0, add the row values and then print the row sum. So once you make this, then what I'm going to do here is I'm going to say for J is equal to 0, J less than number of columns and J plus plus. And what am I going to do? I'm going to do a simple thing here. I'm going to say row sum is assigned the value row sum plus A of I and J. That is, we are getting along the row because we generally travel along the row wise. So we're getting the row sum quite easily. Then once we get the row, okay, I have to just print that particular row sum. Since I do not have a bracket with this inner for loop, only this particular line is associated. That means for each value of J, only this R is sum is equal to R sum plus A of Ij is executed. So what I can do is row sum, I can write like this, row, I can say I plus 1. Okay, this should be right, I plus 1. That is the row I plus 1 because I'm starting from 0 is R sum and I'm going to do end line. So this should give me the sum of the row. So what you're doing here is this is the row sum. So what you're doing is this is row number 1, this is the sum, row number 2, this is the sum. So what I'll do is instead of trying to write the complete program, let me do it in parts, execute and show it to you. So here what I'm doing is I'm traveling through the row. For each row I'm finding the row sum. When J equals the number of columns, this condition becomes false, and for that particular row I'm printing the sum. Then I increase I to the next row. Okay, then I again make row sum 0. If you forget to make row sum 0, your answer will be wrong after the first row, or in fact from the first row itself you will have errors. Then for the second row I'll find the row sum. Once I find the row sum for the second row, at the end of traveling through all the numbers of the second row, I'm going to print the second row sum. So let's do one thing. Let's try to compile and execute it. Okay, here it is. I'm entering a 3 into 3 matrix. So enter the elements 1, 2, 3, 4, 5, 6, 7, 8 and 9. So what should be the sum? First row it should be 6. Next row it should be 15. Then third row it should be, okay, so we have done something wrong. So what is that wrong? Okay, we have not done anything wrong. After the row number we have not given space. Since we have not given space, after 1 it is straight away printing the sum as 6. After row number 2 it is printing 15. After row number 3 it is printing 24. That's why it's looking like that. Let's correct that so that we get it correctly. So what I'm going to do here is I plus 1 row sum. So what I can do is I can give one more space in middle, or I can use a set width of 5. All right, so I can use a set width of 5. So this should work. Let's try doing it now. Let's see what happens. 3 into 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you see row 1 sum is 6, row 2 sum is 15, row 3 sum is 24. So if you give a set width, it will print after a gap of certain spaces, it will give 5 width to row sum, and on the rightmost of those 5 spaces it will print the row sum. That means it will give it 5 boxes. On the rightmost of those 5 boxes it will print the value of row sum. Now let's see how we'll go about the column sum. Column sum is not too difficult, except that you got to watch for one thing. Since you're traveling by column, I is equal to 0, then I'm not going to say I is less than rows. I'm going to say I is less than column, because now I'm changing rows to column and column to row. I want to travel through every column. Then what I'm going to do is I'm going to say column sum is equal to 0. Then using this for loop, for I equal to 0, for j equal to 0, j less than the number of rows, and I'm going to say j plus plus. Then what I'm going to do here is I'm going to say column sum is equal to column sum plus, it is not a of ij, it is a of ji, because I want the columns to be summed up, not the rows. That's why I'm interchanging I and j. This way I'm able to read the columns. Then what I'm going to do here is cout column again, this should be I plus 1, because I refers to the column, I plus 1. Then I'm going to do set width of 5 places. I'm going to say csum, and then I'm going to do a end line. So this should hopefully end up printing the column sum correctly. So here the reason why I'm doing ji is I should be less than the number of columns, j should be less than the number of rows, because we want to find the sum of the columns. So j, initially when j is 0, okay, j refers to the row, I refers always to the column. Since I is fixed, it will always go to the 0th column first, then it will go to the first column, second column, and so on. So I represents the column. So let's try to compile this and run and see whether we are getting the correct results. Alright, so we'll again enter a 3 into 3 matrix. This time I'm going to enter 1, 2, 3. I'm going to enter 1, 2, 3 and 2. Okay, it doesn't matter. 1, 2 and 1, 3, 2 and 1. So if you see here, row sum is 6, next line is 4, next line is 6, which is correct. Column sum is, column 1 is 5, because 3 plus 2 is 5. Column 2 is 6, column 3 is 5. So this should give you how you find the row and column sum. You can do a little bit of decoration, fancy things, but main is getting the correct output is the most important thing at this stage of your learning. Understand the logic and be sure you get the right output. So if you see here, row sum is giving you first, then you're getting column sum. Let me make it a little nice. In the sense, let me do the little formatting. First, let me say, I'm going to say row sum. Okay, so you know that it's going to print the row sum. Alright, and what I'm going to do here is end line. Okay, and then after that, what I'm going to do, I'm going to print the column sum. So this is column sum. I'm going to write an end line. Okay, so what is going to happen is after the last thing, it's going to print the column sum. So let's try running this now and to get a feel of how it looks now after the changed output. 3 into 3. Let me enter different numbers. 1, 9, 9, 2, 4, 5, 5, 1, 1. Alright. So if you see row sum, first one is 18 plus 1, 19. Row 2 is 9 plus 2, 11. Row 3 is 7. Column sum, column 1 is 8. Column 2 is 14, which looks right. Column 3 is 15, which also looks right. So this way you can just adjust and play the formatting. This is how you will end up getting the program output.